This is a fat pet feeder. It's a fully 3D printed automatic Arduino pet feeder I made, and you can make it too. It has a slick design, it fits well in any home. For the owner it's easy to use to clean the bowl, to put more food inside, to set the schedule and portion size. And for the pet it's not intimidating in any way. Why would you ever need one? Well, it keeps the pet diet healthy by scheduling the exact amount of food per day. It keeps the food fresh in the closed container. It's important for my cat at least. You can be sure that your cat, small dog or other carbon-based form of wife is fed when you're not at home. Also, it's pretty cool DIY project for kids, adults, schools or robotic courses. It has a battery compartment, 3 programmable buttons, a precise portion wheel, tight lid. It's modular, easy to print and build. This is the guide on how you can build one yourself. You can get the STLs and the Fusion 360 files at the link in the description. The design is parametric, so you can change the size of the feeder or the bowl in the parameters menu. What off-the-shelf parts do we need? A continuous rotation servo. It's a motor with a gearbox and a driver in one package of standard dimensions. I used Spring RC SM S4303R, but you can use any similar. Any Arduino, I use a Nano clone, but if you feel confident you can definitely use Wi-Fi enabled boards, add embedded cameras, integrate it with smart home services. There are a lot of options here. We need 3 standard size micro switches. These are optional for changing the schedule, the portion size, and to dispense food immediately. A breadboard or a prototype PCB if you want it soldered, some wires to connect everything together, a plastic female DC connector, 4 M4 screws with countersunk heads. I use 10 mm in length, but any would fit. 5 volts 3 amps power supply. A right-angled version is better. Maybe someday I'll make a side socket version of the feeder. Stainless steel bowl is optional, but it can help to avoid cat acne. It's also dishwasher safe. There are several versions in the package, but you can make your own by changing these parameters. For a battery version you need 3D size batteries. According to my calculations, it can work on one set for at least a year. A standalone ATmega 328P microcontroller, or you can break your Arduino to make it less power hungry. I used the same Arduino. A 5 amps boost converter for a motor like LM2587. DS3231 real-time clock module with hardware alarms. An IRL 540N MOSFET. I insist on the L version because it has a lower gate threshold voltage. We needed to turn off the boost converter when it's not in use. Capacitors help with the stable voltage. I use 2, 1 microfarad and 10 microfarads. Battery contacts. I use a steel wire for this purpose. Maybe I'll change the model later to fit the most commonly used ones. All the links to the parts are in the description. As for the 3D printing, Fat Pet Feeder consists of 8 printed parts. It's easy to print if you use decent quality PLA filament. 45-degree overhangs and good 30mm bridges are a must. $20 Isan PLA is good enough in my case. You will need about 0.7 kilograms of filament. I used 3 perimeters with 20% infill, 6 bottom and 8 top solid layers. Default speed. I print parts in this order to be sure that everything fits together and is printed well before it's too late. First one is the hopper, it's the hardest one. Then the portion wheel, wheel compartment, electronics compartment, bowl, shell, for which I recommend adding a brim, even PLA could warp otherwise. Also set the seam position to rear if you want a clean front side. The next is the lid and an optional battery cover. Use this circuit for the wall-powered version, and this for the battery-powered one. The Arduino code link is also in the description. Remove the levers if your buttons have any, we don't need them. After you connected all the electronic parts, put them in your electronics compartment. The motor goes into this slot and the buttons into these slots. This hole is for a DC connector. Put the motor adapter into the wheel. Then you put the hopper, the wheel, and the wheel compartment into the shell. And close it with an electronics part. Use 4 screws to fixate everything in place. Now you can attach the ball part. Close the battery compartment and the lid. And this is how it works. By the way, you don't have to teach your cat to push the button. There is code for scheduled feeding. If you need any kind of support, don't hesitate to contact me in the comments. I'll try to answer every single one, so you don't have to struggle much with printing, wiring or coding the feeder. I want to give away 10 digital models of this pet feeder, 5 in the comments with hashtag #FatPetFeeder and 5 to my patrons on Patreon. Join my Patreon to get all the recent models I release, or maybe you'd like other perks you can get. I'm planning to make other videos regarding battery version, customizations you can make, and the process of making this design in Fusion 360. I'm going to show all the failed prints, different versions and time lapses. Like or dislike this video. If you want to see more of this device, subscribe to the channel. Leave your suggestions in the comments. Your mom will be proud. Customization.
Ёб твою мать! Ох, блядь! Ёб твою мать! Считай нормально, блядь!
And 5 to my patrons on
Patreon!